The next example I'd like to look at uses the product rule to differentiate the function. And the way that we can tell we need a product rule for this problem is I have two expressions, this one here, 4x squared plus 7, and 12x minus 4 multiplied together. Okay, multiplication and product mean the same thing. Now, if we wanted to differentiate this the old-fashioned way, we could just expand these brackets, and then we'd end up with a just straight polynomial that we could differentiate. But we actually don't have to do that if we use the product rule. And the product rule, if you remember, said that if y is a function of two things multiplied together, u and v, then I can differentiate y, find dy dx, by differentiating u, which we sometimes denote u dashed, multiplied by v, and then adding it to the derivative of v multiplied by u. Or sometimes you might even see it round the other way, u times v dash, to keep that alphabetical order going on. It doesn't really matter. The point is the first term has u differentiated, the second term has v differentiated. So let's look at applying that to our problem here. So I've got dy dx equal to, okay, I need to differentiate the first thing, the u. So the derivative of this here is just going to be 8x. I've done that by bringing the power down and reducing it by 1. The 7, of course, becomes a constant. And I need to multiply it by v just the same as it is now. I don't differentiate the v. So I'm going to multiply by my 12x minus 4. Then I need to add my u just as it is. So in this case it's going to be 4x squared plus 7. And multiply by my v dash. So this part here differentiated is just going to be 12. And now we've just got to tidy up. I've got an 8x outside of the brackets here, so I need to go 8 times 12. 8 times 12 is going to be 96. And x times x is going to be x squared, minus 4 times 8 is 32, plus, differentiating here, this looks a bit funny having the 12 outside the brackets, but we can just, I guess on the right hand side of the brackets, we don't normally write it there, we normally write it out the front, but we can still expand by multiplying by each term. So 12 times 4x squared is going to be 48 x squared, and 12 times 7 is going to be 84. And let's have a look here. I can gather like terms together. There's an x squared here and an x squared there. So I have 96x squared plus 48x squared, and that is going to be 144 x squared minus 32x plus 84. And that's going to be the derivative of this function here using the product rule.